Hi students, good morning to one and all. Today we are discussing the topic optimal storage on tapes by using a greedy method. In this concept, we are studying about what is the problem here. Here there are n programs are to be stored on a computer tape of length L. It will associated with each program. I is a length. That's why we can say L suffix I. 1 less than or equal to I less than or equal to n. Let n be the number of programs. Let n be the number of programs. Li be the length of the each program. Let Li be the length of each program. 1 less than or equal to I less than or equal to n. Here we want to be stored n number of programs on a computer tape of length L associated with each program I is a length. So all programs it can be stored on the tape if the sum of length of programs is at most 1 whenever the program is to be retrieved. So a tape is positioned at the front side. Okay, here what I am saying, how much amount of retrieval time required to access a particular program P suffix j, it is denoted by T suffix j. Here T suffix j is assigned to summation of k is assigned to 1 up to j L suffix j, where T suffix j here what it denotes, how much time required to retrieval a particular program. Here K varies from first program to jth program. Up to this, we are adding L1 plus L2 plus L3 plus and so on plus L suffix j. This is the minimum retrieval time. How much amount of time required to access a particular program T suffix j, that is assigned to be summation of k is equal to 1 up to j L suffix j. For example, suppose to take a CD player. In a CD player, we stored 10 songs. Okay, here look at this example. T suffix 9. If you have to play among 10 songs, if you have to play the 9th song, how we can wrote it? 10 songs are there in a CD player. We need a 9th song. Here n is equal to 10. Okay, L1 plus L2 plus L3 plus L4 plus L5 plus L6 plus L7 plus L8 plus L9. Okay, that's why we want to write T suffix 9 is assigned to be summation of k is equal to 1 up to 9 L suffix 9. This is the total retrieval time to access the 9th song. This is the total retrieval time to access the 9th song from the CD player that contains 10 songs in a CD player. How much amount of time we want to access a 9th song among 10 songs in a CD player? Okay, so mean retrieval time is assigned to be 1 by n summation of k is equal to 1 up to j L suffix j. In place of summation of k is equal to 1 up to j L suffix j, we denoted as T suffix j. That means mean retrieval time is assigned to be 1 by n of T suffix j. Here what is a minimum retrieval time? The average amount of time, listen carefully, the average amount of time required to access a particular program among n number of programs is said to be a minimum retrieval time. What is a minimum retrieval time? The average amount of time required to access a particular program among n number of programs, it is said to be a minimum retrieval time. So all programs can be stored on the tape if the sum of the length of programs is at most 1. Whenever the program is to be retrieve in the sense getting, tape is positioned at the front. Okay, if we want to store it in the order I is equal to I1 comma I2 comma and so on up to comma IN, time is to retrieve I suffix j given by T suffix j. Here T suffix j is assigned to be summation of k is equal to 1 up to j L suffix j. This is the pseudocode for assigning a programs. This is the pseudocode for assigning a programs to tapes. Okay, the first step is to be, we have to be stored algorithm store n comma m, where n is the number of programs and m is the number of tapes. Next we have to open the brace. We want to initialize the tape is j. For example, if we have to take j is assigned to be 0, in the sense next tape we want to be stored on. If you have to write some condition for I is equal to 1 to n, do. And if you have to write append program, append in the sense we need to add a program in I comma to permutation for that particular tape in the sense j. Okay, we have to write something operation we have to be performed. J colon is assigned to j plus 1 mod m. Okay, and then if you have to close the brace, if you need to see one example, then if you have to be understand in a clear cut way. Let us see the example now. Here n is equal to 3, n in the sense number of programs. Let n be the number of programs. If we have 3 programs, there are 3 n factorial, in the sense 3 factorial, that in the sense 6 possible orderings is there. 6 possible orderings. The orderings and their respective values are here. Look at here ordering I. Here d of I in the sense some distance or length of I. Here look at this. If we have how many number of programs? 3. The combination of 3 factorial is assigned to be 6. Okay, here look at this. The combinations 1 2 3 here coming, see 1 1 2 2 3 3. Okay, first sequence, see 1 2 3 1 3 2 2 1 3 2 3 1 3 1 2 3 2 1. Okay, this is the 6 combinations of ordering I. Coming to the distance of I, how we can to be calculated, I want to show now. Listen carefully, ma. In this question, the lengths are to be 5 comma 10 comma 3. Okay, I did mistake here. All of you write down in the question L1 comma L2 comma L3, that is assigned to be 5 comma 10 comma 3. Okay, what I am saying, I have to repeat once again, amma. Listen carefully. In the question I did not mention lengths, amma. Listen carefully. L1, if you have to open left parenthesis, L1 comma L2 comma L3 and close right parenthesis, that is equal to 5 comma 10 comma 3. Okay, this is the length anamata. Okay, now if we have to look at the problem here, 1 comma 2 comma 3. Here length 1 is how much? L1 comma L2 comma L3 is assigned to be 5 comma 10 comma 3. That is the question, amma. That is the question. Length 1 is 5, length 2 is 10, length 3 is 3. Okay, understand up to now. Here look at this ordering I. Here d of I in the sense length of I. Here 1 in the sense the first length how much? 5 plus 2 in the sense second length how much? 10. Now if we have to add to be first length plus second length, how much? First length is 5 plus 10. First length it should be 5 plus, and if we have to be add now first length plus second length, first length how much? 5 plus second length how much? 10 plus plus, now if we have to be add first length plus second length plus third length, look at this, 5 plus 10 plus 3, that will be assigned to 38. If we have to be add 5 plus 5, 5 plus 5, how much? 15, 15 plus 20, how much? 35, 35 plus 3, how much? 38. Okay, and likewise we have to solve this. Here look at the second step, 1 comma 3 comma 2. 1 in the sense length 1, how much? 5 plus, now if we have to add length 1 plus length 3, length 1 how much? 5 plus length 3 how much? 3 plus, now if we have to be added length 1 plus length 2 plus length 3, how much? 5 plus 3 plus 10, length 2 will be a 10. Now if we have to add 31, likewise third one only, a third operation I would be same, listen carefully, 2 comma 1 comma 3, in the sense second length how much? 10 plus, if we have to be add a second length plus first length, second length how much? 10 plus first length 5 plus, now if we have to be add second length plus first length plus third length, 10 plus 5 plus 3, how much? 43. Likewise we need to be calculated. Here we want to check optimal ordering here. Now we check optimal ordering here, look at this, 38 divided by 3, that is assigned to be 12.667 approximately. And coming to the 31 by 3, how we can write 3? Here we are taking n number of programs, n is equal to 3. That's why we are dividing j plus 1 by m, j plus 1. Here look at this, j plus 1 mod m. Okay, now here look at this, 31 by 3, that is assigned to be 10.33. 43 divided by 3, that is assigned to be 14.33. 41 by 3, that is assigned to be 13.667. And coming to the 29 by 3, that is equal to 9.667. And coming to the last one, 34 by 3, that is assigned to be 11.33. Here we have to look at the optimal value and best value. It is suitable for optimal storage on tapes. Here I mentioned red ink mark 29. Why? It is the least value, it is the optimal value. That's why optimal ordering is where we can get 3 comma 1 comma 2. Third length how much? 3 plus third length plus first length, 3 plus 5 plus, now we have to be add third length plus first length plus second length, 3 plus 5 plus 10, how much we can get? 29. Now the optimal ordering is 3 comma 1 comma 2, that is assigned to be 29. Approximately 29 divided by 3, how much we get? 9.667. In this concept we are studied about the greedy method. Choose the next program to be stored on tapes. As on that, if we have to be minimizes increase in distance, so we need to store the non-descending order of lengths. Now the greedy method says simply it requires us to store the programs in non-descending order of their lengths. Finally, this ordering can be carried out in order of n log n time. This is the concept. In this concept, the greedy method, we need to choose the next program we want to be stored on tapes. We just minimizes increase in distance. Hence, we need to store the non-descending order of their lengths. Simply, it requires to store the particular program. Here, the ordering can be carried out in order of n log n time. In this question, I doesn't mention the lengths, amma. All of you must and should write in the question lengths L1, L2, L3, that will be assigned to 5, 10, 3. Okay, don't forget, ma. This is the concept of optimal storage on tapes by using greedy method. Thank you, ma. If you have any doubts regarding the optimal storage on tapes, can you please ask me? All of you must and should write in the question, len summa, open left parenthesis, L1 comma L2 comma L3 and close right parenthesis, that will be assigned to 5 comma 10 comma 3. Okay, thank you ma.